Assalamu alaikum and good morning, dear students. Today I am going to discuss a creative question based on periodic properties of element and chemical bond. Students, look at the whiteboard. There are three electronic configurations are given. Students, you can understand easily. Element A is nitrogen, because if I put here the value of N, it will be NH2 2p3 and 1s2 2 4 7. You know that 7 means nitrogen, so A indicates nitrogen. Again, if I consider B, 2s2 2p4 1s2 2 4 8. You know that 8 means oxygen. So students, B indicates oxygen. Again, 3s2 3p3 2p6 2s2 1s2 15 electrons. You know that 15 electrons means this is phosphorus. And based on this step, 4 questions are given. The knowledge based question: what is alkaline earth metal? Elements of group 2 in periodic table are known as alkaline earth metal. Suppose magnesium. Magnesium is an alkaline earth metal. Students, all the elements of group 2 contain NS2 general electronic configuration, and their oxides are basic in nature because they react with acid to produce salt and water. I am showing you an example. Magnesium. Magnesium oxide is basic in nature because it reacts with hydrochloric acid to produce magnesium chloride and water. Number B. Explain the properties of oxides of carbon. Students, you know that carbon can form two types of oxides. One is carbon monoxide and another is carbon dioxide. The properties of carbon dioxide is acidic in nature because carbon dioxide reacts with water to produce carbonic acid, and carbon dioxide reacts with base to produce salt and water. That's why carbon dioxide is acidic in nature. But carbon monoxide does not react with acid or base. That is why carbon monoxide is a neutral oxide. Carbon monoxide is a reducing agent because carbon monoxide can reduces different metallic oxides like ferric oxide to produce metallic iron and carbon dioxide. In this case, the oxidation number of carbon is increased from +2 to +4 by releasing 2 electrons. That is why carbon monoxide is a reducing agent. But dear students, carbon dioxide is not a reducing agent because its oxidation number is 4 and this is the maximum oxidation number of carbon, and there is no scope of releasing any electrons by carbon. That is why carbon can't behave like a reducing agent. So the application of Horn's rule in case of element A of the stat. Students, already I have told you element A means nitrogen, and if I write the electronic configuration of nitrogen very specifically, then it will be 1s2, 2s2, 2px, 1, 2py, 1, 2pz1. Dear students, all you know that p orbital contains 3 subshells and they are px, py and pz, and all those orbitals are degenerate orbitals. I mean their energies are equal, that's why they are known as degenerate orbitals. And in case of degenerate orbital, electrons would like to stay as single electron, and in this case their spin direction must be same, and this is actually Horn's rule, but it may happen but in reality it is wrong, because already I have told you electrons prefer to stay as a single electron with same spin direction. So dear students, I can say the statement of Horn's rule like this: electrons are distributed among the orbitals of a subshell in such a way as to give the maximum number of unpaired electrons and have the same direction of spin. So students, I can say the electronic configuration of nitrogen atom follows the Horn's rule. Students, I would like to remember you, if I write here the electronic configuration, helium, it is 1s2, and there is no degenerate orbital of s orbit or s subshell. That's why Horn's rule is not applicable for helium. So dear students, I am sure that you have understood about the application of Horn's rule in case of nitrogen atom. Students, the question now D. Explain the effect of lone pair electrons on the shape of hydride of AB and C of this type. Students, when it will be asked in the question about the molecular shape or ionic shape, I mean geometrical shape of any ion or molecule, you have to explain this type of question by hybridization. So let's come to the point. The hydrates of nitrogen NH3, what oxygen H2O, and hydrate of phosphorus PH3, I mean phosphine. Dear students, first I would like to show you nitrogen. The electronic configuration of nitrogen is one spherical s orbital combines with 3 dumbbell-shaped p orbitals to form sp3 hybrid orbitals. In this case, 4 sp3 hybrid orbitals are formed. So I can write here, in the hybrid state, sp3-1, 2 sp3-1 and 2 sp3-1. It is stated that among 4 sp3 hybrid orbitals, one sp3 hybrid orbital contains 2 electrons and another 3 sp3 hybrid orbitals contain 1 electron each. Students, you may ask me, sir, I had 3 unpaired electrons, so why should I explain the hybridization? It is stated that the energy of atomic orbital is higher than the energy of hybrid orbitals. So as hybridized orbitals have lower energy, they are more stable. For getting more stable orbitals, hybridization has been occurred here. So students, if I draw here the orbital figure of nitrogen, this is the orbital figure of hybridized nitrogen, and 3 sp3 hybrid orbitals containing single electron overlap with the s orbital of 3 hydrogen atoms to form ammonia. Dear students, you know that in case of sp3 hybridization, the bond angle should be 109 degree 28 minute. But in this case, there is a lone pair electrons. That's why the lone pair bond pair repulsion and bond pair repulsion takes place here, and in this case the lone pair bond pair repulsion is greater than the bond pair repulsion. That's why the bond angle is decreased and it is 107 degree, and in this case the molecular shape becomes trigonal pyramid. Trigonal pyramid. Now, dear students, come to the molecular shape of phosphine. The central atom of phosphine is phosphorus, and the electronic configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3px, 1, 3p, y1, 3pz1, and one spherical s orbital combines with 3 dumbbell-shaped p orbitals to form sp3, 3 sp3 hybridized orbitals here. So in the hybridized state, the electronic configuration is 1s2, 2s2, 2p6, 3sp3, 2, 3sp3, 1, 3sp3, 1, 3sp3, 1. Students, there are 4 sp3 hybrid orbitals, but one sp3 hybrid orbital contains 2 electrons and 3 sp3 hybrid orbitals contain 1 electron each. So if I draw the orbital figure of phosphorus, it will be like this. Three sp3 hybridized orbitals containing single electron overlap with the s orbitals of 3 hydrogen atoms to form phosphine. Students, as it is a as here sp3 hybridization takes place, the bond angle should be 109 degree 28 minute. But due to the presence of lone pair electrons, there is a repulsion of lone pair bond pair and bond pair takes place. But the lone pair bond pair repulsion is greater than the bond pair repulsion. That's why the bond angle is decreased and it becomes 92 degree, and the molecular shape is pyramidal. It is stated that in case of sp3 hybridization, the molecular shape is tetrahedral, but due to the lone pair bond pair repulsion is greater than bond pair repulsion, the molecular shape is pyramidal. Dear students, now you may ask me, sir, the hybridization and the arrangement of the bond pair and lone pair electrons of phosphine is similar to ammonia, but the bond angles are different. What is the reason? The main reason, atomic size of phosphorus is larger than ammonia. So the electronegativity of phosphorus is lower than nitrogen. That's why the bond pair electrons, the bond are extended, nitrogen hydrogen bonds are extended, and the bond angle is more decreased due to the pressure, due to the more influence of lone pair electrons. That was, it is decreased 92 degree. But in case of nitrogen, when the electronegativity of nitrogen is more than phosphorus, that's why the bond pair electrons are pulled to nitrogen, and in this case nitrogen hydrogen bond is not extended like phosphine. So here the influence of lone pair electron is less than phosphorus, is 170. This is the difference of bond angle between phosphine and ammonia and the reason of different bond angles despite their hybridization arrangement and the general electronic configuration of last shell of central atoms are same. So students, I think you could understand about the similarities and dissimilarities between ammonia and phosphine. So come to the another element, that is oxygen, and already I have told you the hydride of oxygen is water, and if I show you the electronic configuration of the central atom of water, we will see that oxygen contains oxygen contains 6 electrons at its last shell, 1 spherical s orbitals and 3 dumbbell shaped pi orbitals combined together to form as 4 sp3 hybrid orbitals. So in the hybridized state, I can write here 1s2, 2sp3 2, 2sp3 2, 2sp3 1, 2sp3 1. Dear students, I can say here among 4 hybridized orbitals, 2 orbitals contain 2 electrons each, and another 2 orbitals, hybridized orbitals, contain 1 electron each. So if I draw here the orbital figure of oxygen, hybridized oxygen, it will be like this: 2 electrons, and sp3 hybrid orbital, 1 electron, sp3 hybrid orbital, 1 electron. 2 sp3 hybridized orbitals containing a single electron overlap with the s orbital of 2 hydrogen atoms to form water. Here lone pair repulsion, lone pair bond pair repulsion, and bond pair repulsion take part. Dear students, in this case lone pair repulsion is greater than bond pair repulsion. Lone pair bond pair repulsion and is greater than bond pair repulsion. As a result, though the bond angle should be 109 degree 28 minute, but due to this phenomena the bond angle is decreased and it becomes 104 degree and the molecular shape is bent. So dear students, I am sure that you could understand about the effect of lone pair electron on the molecular shape of hydride of nitrogen, phosphorus and oxygen. Students, this is a very important question for your board exam. So everybody, please study this creative question, write it on your copy, and hope you can memorize it very easily. No more today, and goodbye.